So I called this Components of the Universe, of stars and planets and black holes and the unimaginably huge distances between them. If there's one thing I want you to get out of astronomy, it's that the universe, even our solar system, is far bigger than our brains can wrap around easily. I have a math degree and I can't make much sense of the numbers. All I know is they go from really big to really, really big to holy smokes, that's incredibly big, to I give up, I can't go that big. And that's really our biggest challenge in star travel, Matt. It's the distances. The distances are enormous. But we will talk about aliens and star travel and stuff like that too. So let's start out. Definition of a solar system. Well, a solar system is a group of planets circling one or more stars. Oh, the screen is still frozen. There we go, that works better. Solar system is a group of planets circling one or more stars. Wow, the writing is kind of embedded in there, isn't it? That's a problem. Hopefully it vanishes. I think my bulb is dying. Definition of a planet. See, there was a problem. We never defined a planet, and initially our definition of a planet was very incomplete. So we said this: a planet is a celestial, that's the fancy word for in outer space, celestial body that orbits one or more stars. A planet is a celestial body that orbits one or more stars. This definition is incomplete, though, and it's going to lead us to a problem that we call Pluto, and we'll talk about that later on. The Earth spins around its... I'm going to have to write, I think. The Earth spins around its axis. How long does it take the Earth to spin around once? Can you give it to me in hours? Okay. Every 24 hours. And this spin is called its rotation. The Earth rotates around its axis. How fast? Well, about 1,670 kilometers per hour if you're standing on the equator. It's a little slower as you move further and further north or south because the circumference as you go, because the Earth goes like this, so as you go further and further north or south, the circle that you're spinning is smaller and smaller. In fact, technically at the North Pole, all you're doing technically at the North Pole is doing this every 24 hours. And same with at the South Pole. What that means is, if we somehow magically stopped the Earth instantly, all of you would go flying into the wall at 1,670 kilometers per hour. Here's my question. Which wall? We're going to come back to that, but I'll let you think about it. Okay? The Earth also revolves around the sun. So it rotates around its axis. It revolves around the sun every, how many days? Approximately 365. It isn't exactly 365 days, but it's close. It's almost exactly 365 and a quarter days, which is why every 4 years we have a leap year. We add that extra quarter day, 4 times a quarter as well. But it isn't quite. It's actually a little bit less than a quarter, I think less than a quarter. And so every 100 years, we don't have a leap year, even though a leap year goes into 100, 4 goes into 100. So the year 1900 was not a leap year. The year 1800 was not a leap year. But that's not quite enough as well. Every 1,000 years, we do have a leap year, even though 100 goes into it. So the year 2000, even though 100 went into it, because 1,000 went into it, we did have a leap year that year. And then there's one more thing that we're going to have to do, I think in the year 11,000 sometime, but I don't plan on being around to fix that. But eventually we'll be one day off again. This is called its revolution. So the Earth has a rotation, 24 hours, it has a revolution. How fast does the Earth revolve around the sun? I know. Oh, sorry, didn't see this. Let me just pause the video here. It's okay, no. Okay, so we're actually moving around the sun crazy fast. Basically 110,000 kilometers every hour. That's pretty fast. That's faster than we're spinning, than we're rotating. Different planets have different periods of rotation. We call the period of rotation a day. And they have different periods of revolution. We call the period of revolution, begins with letter Y, a year. There is one planet whose day is longer than its year. Only one. Which one? Anybody know? So there's one planet, it takes longer for it to spin around once than it does for it to go around the sun. Venus. Takes 243 days for it to spin around once. Takes 224.6 days for it to go around the sun. Hashtag nerd trivia. I'm not going to make you memorize that, but, you know, kind of cool. Put your pencils down, look up. So, we believe that there used to be a star somewhere in this location. It exploded, the fancy word we say it went supernova, and it left behind a cloud of dust called a nebula, and gradually that cloud of dust and debris coalesced into planets and another star. Anybody know what we call our star? Our star has a name. It begins with the letter S, not called the sun, it has an actual scientific name. Called Sol, S-O-L, from which we get our word solar. Ah. Okay. Before I let you go, I asked you a question earlier. If the Earth stopped spinning, which wall would we all go flying into? Can you give me a compass direction, please? North, south, east, or west? East. Okay, can we agree it's not going to be north or south? Okay, so let's see if we can reason this out. That way is east, that way is west. Which way does the sun appear to move to us? Okay, the sun looks to us like it's moving that way. Is it moving? No. So it's because we're spinning. We are spinning to the east. So if the Earth stopped, we would all go flying into the east wall. That wall there. Hashtag nerd trivia. So I'd finished off, or I'd looked at a little nerd trivia. Venus is kind of cool because on Venus, a day is longer than a year. It takes longer for Venus to spin around once than it does for it to revolve all the way around the sun. I'm not going to ask you that on a test, Danielle. That's purely nerd trivia. It's kind of cool. And we saw a little video on the formation of the solar system. We're going to talk more about that as we go. So, our solar system formed around, where's my pen? There's my pen. 4.5 billion years ago. We figured the universe is around 13, a little more than 13, close to 14 billion years old. So our solar system has only been around in the final third or so of the universe's existence. There was a star here earlier that went supernova, that exploded, and from its remnants, the sun and all of the planets formed. There are 4 inner planets. Does anybody know the 4 inner planets? Go ahead. Give me one. Mercury. Let's see if we can go in order outwards from the sun. Mercury is closest to the sun. Venus. Venus is often called Earth's sister or Earth's twin. It's almost exactly the same size as Earth. It's almost exactly the same gravity as Earth. The only problem with Venus, it has a runaway greenhouse effect. The greenhouse gases and the greenhouse effect on Venus, the temperature on Venus is enough to melt lead. The Russians in 1975 managed to land a probe on Venus, and it lasted for about 2 hours before melting. That's the only pictures we have of Venus. Even today, we really haven't managed to build something that can land on Venus. We can go in the atmosphere, we can send satellites and take pictures, but landing on Venus, otherwise, we wouldn't be talking about going to Mars. We'd totally be talking about going to Venus because the gravity is almost identical. It's closer. It's a nice little planet, aside from the fact that it's about 1,000 degrees there. Okay. Next one is us, Earth. And Mars. These are also called the terrestrial planets. And these 4 planets all have certain things in common. First of all, they're small relative to the other planets. Earth seems pretty big. No, it's really not. And they have solid cores and rocky crusts. They're made out of rock. There are 4 outer planets. If we keep going out from Mars, what's the first one that we hit? Jupiter. What can you tell me about Jupiter? Any interesting facts? There's one that you should know. It's the biggest. Okay, by far. It's by far the biggest. It has some spectacular... Jupiter, I went on my rant. It's really worth looking at through binoculars. You'll see it go from a twinkly dot to a round circle with a good pair of binoculars, even with only an okay pair of binoculars. Yeah. You can't? Yeah, it's the, I think, 4th brightest object at night. Moon, ISS, Venus, Jupiter, I think is what it is. It's got that big red spot, if you see it in pictures. It's a beautiful planet when you see it in color photos. It's like, wow, that looks pretty cool. Okay, keep going out. What do we run into next? Saturn is probably the prettiest planet. It's got those rings. Right? Keep going out. It's pronounced Uranus. It is not pronounced the way all of you want to giggle and pronounce it. It's actually pronounced Uranus. Keep Neptune. And then when I was a kid, I would have gone one further and I would have said Pluto. And we're going to talk about why Pluto is no longer considered a planet. Pluto has been in the news a lot in the past year. If you're a bit of a nerd, you may have followed that New Horizons probe that arrived there this past summer and gave us some spectacular pictures, some gorgeous photos, and we're learning all sorts of weird new stuff about Pluto that we didn't know before. The problem with that New Horizons probe is when they launched it, Pluto was still a planet. And then shortly after they launched it, Pluto was demoted. So the people who were in charge of that particular research project were like, we thought we were going to be exploring a planet. Now we're exploring something different. What can we say about these? They're larger. They're much colder. Okay. And they have large gaseous bands. They have these colored bands because of the way the winds blow on them. They're really pretty cool. Especially Jupiter and Saturn. If you see them in color photos, it's like, oh, that looks really nice. Like if a painter painted that, I would say, that's a nice painting. It's pleasing to the eye. I wrote down here, see page 386 in your textbook for a lovely summary of the planets. We'll actually be going into more detail. You are going to want to bring your textbook next class. You are going to want to bring pencil crayons next class. I'll have some, but if you want cool, unusual colors, mine are pretty basic. If there's one thing, Jaden, that I want you to come out of this whole astronomy unit with, it's that space is big. It's fantastically, mind-blowingly impossible to wrap my brain around big. Even our solar system is big. Because the distances are so huge, astronomers use astronomical units, or AUs for short, to measure distances. Astronomical units, or AUs. One AU is the distance between the sun and the Earth. We use that as our measuring stick. So if an object is 8 AUs away, that means it's 8 times the distance between the sun and the Earth. Is that okay? We got to use something, and believe me, meters and kilometers are too small. The distances are way too big. 1 AU is approximately 150 million kilometers. Most of you, if you've looked at pictures of the solar system, have a completely wrong idea of the scale of the solar system. And in fact, in a couple of days, each of you is going to make your own solar system to scale, and you're going to find, holy smokes, the planets are nowhere near where I thought all the planets were. In fact, I didn't even know this until I came across this activity. It's like, wow, I was totally wrong. If I was imagining Pluto here and the sun here, and I was spreading the planets out between them, I had them all in the wrong locations. I had them in the right order, but I didn't realize how far apart they were. The sun. This is the center of our solar system. It contains more than what percent of all of the mass of the solar system? Does anybody know how much of the mass, if you add up all the planets and the asteroids, how much of that mass is the sun? Higher. 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 99. Almost all of the mass of our solar system is the sun. The planets and the asteroids and the comets and the Oort cloud are the remaining 1%. Put your pencils down. Certain parts of the sun. The first one we call the corona. The corona is the outermost part of the sun's atmosphere. It's in my picture here, the glowy, dark, orangey stuff. And it's only visible during an eclipse. Nerd trivia, it can reach about 3 million degrees Celsius. It's hot, but not the hottest. Then there's something called a solar prominence. Just to show you how big they are, I found this picture. There's the approximate size of the Earth. Here is a solar prominence. I tried to tell you that the sizes we're dealing with are bigger than we can wrap our brains around. This is small still. Okay? What's a solar prominence? It's a huge, superheated loops of gas that erupt from the sun. It's a loop, Ibrahim, in that it ends up coming back into the sun, doesn't leave the sun. If it leaves the sun, we call it a solar flare, if it manages to break off. We'll talk about that. Some other parts of the sun. Sunspots. By the way, I should, because I got coal in this, please don't look at the sun with your bare eyes. I should mention that warning, right? And you should look at, also not through sunglasses. It's probably safe to do it through like welder's glasses maybe. But you know what? I'll take that back. I have to look that up first. Don't look at the sun. What are sunspots? Sunspots are intense magnetic storms on the surface of the sun. We call them sunspots because, Matt, they're slightly darker than the surrounding areas because they're slightly cooler. And they move. This was, in fact, the first evidence that astronomers had that the sun was not a solid sphere, that it was not made of rock like the Earth, that it was made up of churning plasma and gas. Oh, yeah, turn the page. See page 384 in your textbook. So if you want to open to page 384, if not, I have it here as well, and I'll zoom in. Okay. So, I think I can zoom in a bit more even. Solar prominences, large loops of super hot gas that extend from the sun's surface. There's a solar prominence. They tend to be associated with sunspot activity. Also, violent eruptions of gas called solar flares occur. These ones actually leave the sun. Dark patches, these are sunspots. Some of them can be bigger than the width of the Earth. They're a little cooler. Sunspots increase and decrease on a roughly 11-year cycle. Photosphere, this is the part of the sun that's the most familiar to us. This is what we see. It's called the photosphere, the bright, owie, don't look at with your eyes part. Okay. Reaches about 5,800 degrees Celsius. The chromosphere is the outermost part of the sun's atmosphere is the corona, and then beneath that lies the chromosphere. So corona, that's the shiny part that we can't see except during an eclipse, the chromosphere. So there's a picture. Which of these do you need to know? That's really what you're wondering, Mason. Well, I'll tell you. I will ask you these parts in your homework. In your homework, you'll be all of these parts from page 384. Just fill them in. But the ones you need to know on the test are those three. You might want to write those down. Corona, solar flare, and sunspot. You okay, Matt? That was a long blink. Put your pencils down, look up. Talk about the northern lights in more detail later on. Matt, you gonna make it? You're not foolishly looking at your phone or anything like that, are you? No? Can you move your backpack off the desk for me? Thank you. Looks like you're trying to hide behind there. No, never. Thanks, kiddo. Let's keep going. I was going to show you how the aurora works. I'm not going to. We're going to move on. Planets and the size of the solar system. So recall, we said there were 4 inner or rocky planets. It was Mercury, Venus, Earth, Mars. And then we have the 4 outer or gaseous planets. Jupiter, Saturn, Uranus, and Neptune. And every time I write that, Brooke, I always get a little sigh of sadness because to me, it's missing Pluto. But I recognize why we have decided that Pluto is no longer a planet. Hey, how do you organize a space party? You plan it. Tough audience. Some pictures. So here is a picture of the Earth compared to the Sun. I told you that stuff is really big, tough for us to wrap our brain around. Here's a picture of the Sun. There's Jupiter, there's Saturn, there is Venus and the Earth. No, sorry, there's Uranus and Neptune. There's the rocky planets right there, the 4 small ones. If you take the distance between the Earth and the Moon, you can just squeeze in all of the other 7 planets quite nicely side by side. Just fits. with about 8,000 kilometers to spare. North America, if you put it on Jupiter, would be that big. Yeah. And we haven't gotten big yet. This is still, I can kind of wrap my brain around this. Would we really get it? No. Pluto. Planet or not? Well, back in my day, Pluto was a planet. Astronomers, among them one of my nerd heroes, Neil deGrasse Tyson, demoted Pluto back in, I think, 2005. And because Neil deGrasse Tyson is on TV a lot, and he wrote a book about it, and he runs the Hayden Planetarium in New York, he was fairly outspoken. He actually got hate mail from children. I kid you not. Put your pencils down. Here's the first one. Let me make it bigger. How do I zoom in here, Mr. Dewick? Here it is. Zoom in. Zoom in, 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 zoom in. I'll read it. It says, Dear Mr. Tyson, I think Pluto is a planet. Why do you think Pluto is no longer a planet? I do not like your answer. Pluto is my favorite planet. You're going to have to take all of the books away and change them. Pluto is a planet! Exclamation point, exclamation point, and then I love it. Here's a picture of Pluto crying. And then here's Saturn, and what does it say next to Saturn? I miss my friend! Here's the next one. It says this. Dear scientist, what do you call Pluto if it's not a planet anymore? If you make it a planet again, all the science books will be right. Do people live on Pluto? If there are people who live on Pluto, they won't exist. Why can't Pluto be a planet? If it's small, that doesn't mean that it doesn't have to be a planet anymore. Some people like Pluto. If it doesn't exist, then they don't have a favorite planet. Please write back, but not in cursive because I can't read in cursive. Your friend, Madeline. What's first? Oh, yes, typed. Okay, this guy's going to bring it. Ready? My name is John Glidden. I am 6 years old, and my favorite planet is Pluto. I disagree with you that Pluto is a Kuiper Belt object. I think Pluto is a real planet, and I took a poll of 11 people. Do you see? He's bringing the science. He's doing research. The question was, what do you think Pluto is? A planet? A double planet? A Kuiper Belt object? I think it is a double planet, and everyone else thought it was a regular real planet that is very cold. I had a half day at school yesterday, so my mom brought me to the Museum of Natural History and the Hayden Planetarium. I wanted to see you so I could tell you this in person. You know what he's saying? I know where you work. Right? I mean, this kid's serious. I know. I'm coming for you. I'm coming for you. John Glidden. But eventually people understand the reasons and the anger passes. It says this, Dear Dr. Neil Tyson Degrasse, at first, remember all of those kids that sent you bad letters? Well, I want to apologize all of the things we were wrong about. We're sorry about giving you mean letters saying we love Pluto but not you. I'm very sorry. It'll be okay. Taylor, age 7. And then the last one. Dear Dr. Neil deGrasse Tyson, I know how you feel. We feel the same about Pluto not being a planet. But we just have to get over it. That's science. We have to learn about science. Science will make you smart. Love, Siddiq, age 8. So, Dr. Tyson got hate mail from kids, and he got a bunch of these. These are just a few that he put in his book. But we had a historic moment only 1 year ago. This occurred. So what's the science behind all of this? Well, these are the three conditions that a planet has to have. We had never defined what a planet was. We added three conditions. You might want to put a star next to these three. These might be three that I might ask you on a test. The first condition to be a planet, it has to orbit the sun. The second condition to be a planet, the second condition, it has to have pulled itself into a sphere under the influence of its own gravity. The third condition to be a planet, it has to have cleared out its orbit from all other debris. Does Pluto orbit the sun? Yep. Has it pulled itself into a sphere under the influence of its own gravity? Yep. But it has not cleared out its orbit out of other space debris. Pluto doesn't pass that condition there. We had to define a planet because we'd reached a situation where either we were going to have 8, like we have now, or 13, because we'd found other stuff besides Pluto. Did you know that? I'll show you. First of all, we found planets in other solar systems. This is from a couple of years ago. This is from the comic XKCD. He did all 786 known planets to scale. This is already out of date. That was 2012. We now have, I've changed this every year. On March 5th, we had 2,086 planets, and counting. We had found more, not in our solar system, Josh, but around other stars. Which is important. By the way, when I was in high school, we hadn't found a single planet on other stars. We didn't know we thought perhaps that only our star had planets, that planets were very rare. We now know planets are not only rare, we now know that if you find a star, it's more likely that that star does have planets than doesn't have planets. And there are billions and billions of stars out there. Pluto belongs to an entirely new category called dwarf planets. They have a fancy name as well. I'm not going to make you memorize the fancy name, but I'm going to give it to you. They're also called Trans-Neptunian objects. Objects past Neptune. Dwarf planets. Little hashtag nerd trivia. You see, the problem, Sierra, was we had found other stuff. Eris, for example, is a dwarf planet. It's 25% larger than Pluto. So if we were going to include Pluto, then, Hannah, we better include Eris. It was discovered in 2005. It's about 3 times further from the sun than Pluto, but it orbits the sun, and it's pulled itself into a roughly spherical shape. It has not cleared out its orbit of space debris. Here's a picture of the current dwarf planets, or trans-Neptunian objects. So we have Pluto, Pluto's moon Charon. We have Eris. Several were found by the observatory in Hawaii, and so they have Hawaiian names. So there's Haumea, which is kind of egg-shaped. There's, I think it's pronounced Maki-Maki. And we're finding more. We're finding more. Just recently, and I haven't added this to the notes, in the past few months, a research paper was published. It suggested that there might be one big massive planet further out there that we haven't found yet. In the Ray Brook, we figured that out, is something out there seems to be influencing other bodies with its gravity. So we think there might be, but it's still speculation. Another big massive planet, a 9th planet, way out there, like 10 or 15 times the distance of Pluto. And we may never find it. It's that far away, we can't see stuff that far away. Or maybe we can. Other components of the solar system. Asteroids. Asteroids are chunks of rock orbiting the sun. Most of them are found between Mars and Jupiter in something that we call the asteroid belt. And now I got to go on a rant. You've seen space movies, Star Wars as a classic one, where the Millennium Falcon goes dodging through the asteroid belts, dodging rocks. TIE fighters are smashing into rocks behind it. That's garbage. The asteroid belt is actually almost all empty space. There's some rocks there, but the odds of you running into a rock, Brian, are basically zero. We send probes through the asteroid belt all the time, NASA does, and NASA doesn't even bother worrying about hitting a rock while going through the asteroid belt. It's empty. So what you see in movies, Brady, with rocks everywhere, that's garbage. That's garbage. Asteroid belts aren't like that. End of rant. What else do we have? Comets. Comets are balls of ice and rock. They also orbit the sun, but they orbit the sun at the far edges of our solar system. If you go out from the sun, if you go out past the planets, if you go out past Pluto, if you keep going, you run into something that we call the Oort cloud. It's a cloud of debris and rock and comets. Some, like Halley's Comet, many people pronounce it Halley, but actually in Britain, since he was British, it was Halley, have very regular orbits. Halley's Comet comes by every 76 years, and it's big. It came by when I was in high school in 1986, and it was a big deal, but it didn't come by very close. The viewing wasn't very good. In 1910, it actually, I think, was visible. It might even have been visible during the day. It came by so close that the Earth passed through its tail. It's next, 1986 plus 76. You guys, when you're my age, will probably get a chance to see Halley's Comet. I'll be long dead by then. Probably. You know what? 98? I could be still kicking around. Maybe. Okay. What's the main difference between an asteroid and a comet? A comet... Come on, pen. Okay, let's try it this way. Has a tail. Because it contains ice. As it gets close to the sun, the ice starts to melt and vaporize like steam, and then the sun shines through that steam, making the steam glow like a tail. The tail always faces away from the sun. Faces away from the sun. Okay. I'm going to show you the Oort cloud video another time. But how are comets, asteroids, and meteors different? Put your pencil down. Asteroids are kind of the interesting one. Occasionally, one of these asteroids gets bumped out of its normal orbit and comes into the inner regions of the solar system, and sometimes close to us. We believe this is what killed off the dinosaurs. Put your pencils down. So, the real reason dinosaurs became extinct? No, it wasn't because they started smoking. Here's the real problem. The real problem is going to be when the huge asteroid hits us in the year 2034. You hadn't heard about the asteroid in 2034? Well, put your pencils down.